some of history's greatest cold cases? Well, they're being reopened. But the new detectives on the scene aren't digging in the dirt with trowels. Nope. They're data scientists, and their tools are statistics and artificial intelligence. And believe me, they are rewriting what we thought we knew about our past. Today, we're going to look at two legendary puzzles, the so-called uncrackable script of the 4,000-year-old Indus Valley civilization and the incredibly controversial Shroud of Turin. For decades, these mysteries, kind of like the famous Voynich Manuscript, they just seemed permanently locked. But now, powerful new tools are looking at the same old evidence in a completely new light. And we're going to start with this Shroud of Turin. Now, for a lot of people, this was a case that science had definitively closed over 30 years ago. The official story was clear, and frankly, it seemed final. The shroud's got a long, well-documented history. It actually survived a fire way back in 1532. Fast forward to 1978, a huge scientific investigation concluded that the image on it wasn't a painting. But the key event, the one that everyone points to, happened in 1988. A sample was sent to 3 of the world's leading labs for radiocarbon dating, a test that was supposed to settle the question of its age, once and for all. And the result came back with what felt like absolute mathematical certainty. The labs dated the cloth to the Middle Ages, placing its origin squarely between the years 1260 and 1390 AD. So this is the crucial point here. This wasn't just one opinion. This became the scientific consensus. You had the world's best dating technique performed by the world's best labs, and they had spoken. For all intents and purposes, the case was closed. The shroud was a brilliant, but ultimately medieval, fake. But then, decades later, a new team of scientists decided to re-examine the whole thing. And get this, they didn't even take a new sample from the shroud. No, instead, they got their hands on something even more fundamental, the original raw data from those 1988 tests. And they asked a very, very powerful question. What if the data, the very same data everyone had relied on for 30 years, had been hiding a secret all along? What if it actually told a completely different story? Okay, so right here you can see the first crack in the official story. When statisticians looked at the mean results from each lab, they found a huge problem. Oxford's average was over a century older than Arizona's. These results weren't in agreement. In fact, they were statistically different from one another. This led them to a pretty startling conclusion, which is summed up perfectly in this quote from their 2020 analysis. To put it simply, you can't just average these numbers together and call it a day. The basic assumption that each lab was measuring the exact same thing was statistically invalid. But why were the results so different? Well, the answer was the statistical bombshell. Buried deep in that old data was a bizarre trend that no one had noticed in 1988, something they call a spatial gradient. The age of the sample wasn't uniform. It systematically got younger from one end of the strip to the other. And this number, wow, this just shows you the scale of the problem. The analysis found that for every single centimeter you moved along that tiny sample, the radiocarbon age changed by about 50 years. That is a massive, systematic variation which makes a single average date completely meaningless. So what does this all mean? Well, the best analogy is this. Imagine you're trying to date a priceless ancient carpet, but the only sample you're allowed to test is from a corner that was visibly stained and rewoven centuries later. That patch is contaminated, right? It's got newer threads, newer carbon. The date you get back would tell you nothing reliable about the age of the carpet itself. And that's the argument. The 1988 sample was simply not representative. Okay, let's pivot. We're going to turn from a case being reopened to one that might be cracked for the very first time. We're going to the ancient Indus Valley, home to one of history's most famously undeciphered scripts. For over a century, scholars have stared at symbols just like these, found on thousands of artifacts. These copper plates right here, they're about 4,000 years old, and they contain a message from a lost world that no one has ever been able to read. And the challenges here, they are just immense. I mean, first, there's no Rosetta Stone, no handy parallel translation. The language appears to have no living descendants. The inscriptions themselves are incredibly short, which makes it really hard to find patterns. And to top it all off, there are over 400 unique symbols to decode. For 100 years, this just seemed impossible. But where human codebreakers have failed, a totally new approach is making incredible progress. We're talking about using computational linguistics and artificial intelligence to see patterns that the human eye simply cannot. So how does this even work? Well, first, computer vision goes through and digitizes and isolates every single symbol. Then machine learning algorithms go to work, looking for recurring sequences of 2, 3, or more symbols, trying to map out potential grammar rules. The AI then compares these statistical patterns to other ancient writing systems before finally trying to reconstruct a whole framework of meaning. It's really an incredible process. The AI is essentially acting like a superhuman codebreaker. It can process thousands of inscriptions at once and detect these super subtle, context-dependent relationships between symbols that have been hidden in plain sight for a century. And the results? Well, they're just stunning. This is one of the proposed translations to come out of the analysis. And far from being a simple list of goods or names, the script seems to encode these profound philosophical and spiritual concepts. And this is the truly revolutionary part. For a long, long time, the main theory was that early writing systems were just invented for practical stuff. Accounting, keeping inventory, administration. This finding turns that whole idea on its head. It suggests the Indus script was actually a sophisticated vehicle for encoding complex theological and metaphysical knowledge. So, after all this, where do we stand? Well, in both cases, these new data-driven analyses haven't given us a final, definitive answer. But what they have done is maybe even more important. They've overturned a flawed consensus and they've reopened the investigation. This really sums it up perfectly. For the shroud, we've moved from confirmed forgery to the original dating is invalid and its true age is actually an open question. For the Indus script, we've gone from an uncrackable administrative code to a potentially readable text of deep philosophical meaning. The shift in both cases is absolutely dramatic. And, ultimately, this is what it's all about. Science isn't some dusty book of facts that never change. It's a dynamic, ongoing process. With new tools like robust statistics and AI, we can ask new questions and constantly refine, and sometimes completely overturn what we thought we knew for sure. Which leaves us with a pretty fascinating final thought, right? If these two monumental historical conclusions could be upended just by a fresh look at the data, what other truths that we all take for granted are just one data set, one algorithm, or one new question away from being completely rewritten?